So now that we're comfortable taking vectors and breaking them up into their components, we want to come back and add a couple of operations that we can do with vectors. And the first one of these is going to be vector addition. So let's start with, well, what does it mean to add together a set of vectors? So we know what it means to add together a set of numbers, but vectors have both magnitude and direction. And so how does that change what the process is when we have to add together vectors? And so let's say I want to add together three vectors, a, b, and c. So vector a plus vector b plus vector c. And what I'm going to get when I do that we'll typically refer to as the resultant vector. So r over here on the right hand side of my equation standing for the resultant. And so let's just take three vectors here that I've labeled a, b, and c. And so the first thing that we're going to do is state graphically what we're doing when we add these vectors together. And graphically, to add together vectors, you're going to draw them what are known as tail to tip. So what that means is in this diagram over on the right, instead of drawing all the vectors from the same origin, what I'm going to do is I'm going to first draw vector A, and then I'm going to draw vector B starting where vector A ended. So notice that the tail of vector B is drawn from the tip of vector A. Now I'm going to draw in the tail of C starting from the tip of vector B. So what we're doing is we're basically drawing the vectors, but instead of drawing them all from the same point, I'm drawing them consecutively. So sort of one right after the other. And then the resultant vector is the vector that starts where I started my first vector and runs to where my last vector finished. So in this case, when I draw A, then B, then C, I'm going to draw in the resultant starting from the tail of A and draw it into the tip of C. And in this case, that happens to be a vector that points straight in the negative y direction. Now, one thing to be clear about is that just like with adding numbers, order doesn't matter in adding vectors. So instead of starting with A, then drawing B, then drawing C, I could effectively do this in the opposite order. I could start with C first, and then where the tip of C ends, I'm going to draw in the tail of B and go ahead and draw B straight down, and then draw in A starting from the tip of vector B. What you notice is that when I come back and draw in from the tail of vector C to the tip of vector A in this case, I get the exact same resultant vector. So it doesn't matter how you draw out your vectors graphically, A plus B plus C, you should always get the same resultant. So part of what we want to emphasize is that there are really two important diagrams, vector diagrams, that we can make when we're doing a vector addition problem. The one over on the left, where we're drawing all three vectors A, B, and C from the same origin, that diagram is going to be incredibly useful to break our vectors up into components. So effectively, we want to see how each vector relates to our x and y coordinate axes, and we want to do that where all of them have been drawn at the origin. Our diagram on the right, on the other hand, it shows us the vector addition. And so this is the way that we get to see the resultant vector, what we're going to end up with when we add all three of these together. So it may be a situation where you're given a problem where the information you're given is easy to draw the diagram on the left first, or you may be given a problem where you're told the vector addition piece, and so you actually start by drawing the diagram on the right. We will, for most vector addition problems, come back and draw both these diagrams because they both serve a purpose. They're useful in their own way.